We can write a system of linear inequalities very similarly to how we wrote a system of equations, using two equations if we're going to use two variables, three equations if we need three variables, and so on. So in this case, let's take a look at what's going on. We want to make sure that we work at most 40 hours. So that's we're going to again kind of think of these as two equations, where one equation, or inequality I guess I should say, is going to be about the amount of hours we work. And one of them is going to be about the value, although in this case value is going to be really more like what we earn. But we can think of it as those two inequalities. So we want to work at most 40 hours, and let's see, we have to make at least $275. So our $40 is our amount that we're working, the $275 is going to be the value that we want to achieve. So the two jobs that we're working, one job pays us $10.50 an hour, the other job pays us $6.75 an hour. So because both jobs start with a B, we have babysitting and we have Best Buy, we have to be kind of careful with my variables. I suppose if you want to use X and Y, you can. What I'm going to do is say I'm going to use B1 to stand for babysitting, and then I'm going to use B2 to stand for Best Buy. And if you want to use different variables, that's fine. Just make sure you identify what's what. So for my amount of hours I work, there's no value attached to that. That's just purely number of hours. So I'm going to say B1 plus B2. Those would be my 2 hours I work together. And I know that I need to work at most 40 hours. So I'm going to skip over my inequality symbol for just a second and put the 40 down here. Now, to express at most 40 hours, I want to make sure that this amount I work is underneath 40. So I want to make sure B1 plus B2 is less than 40. And because it said at most, I suppose I could max out at 40, so I could be equal to. So I'm going to say B1 plus B2 has to be less than or equal to 40. Now, for your value equation, this is where I'm going to include what I make per hour. So while I babysit, I make $10.50 an hour. So I'm going to say $10.50 times B1, the amount of hours I spend babysitting, plus $6.75, the amount that I make per hour at Best Buy. And I want to make sure that the amount I make is greater than or at least $275. So again, I'm going to skip over the inequality for a second and put down the $275. Now, the amount of money that I make is over here. I want to make sure that that is at least $275. So in other words, greater than $275, or like at a minimum, I could be equal. So I'll include the equal to bar. So there's the system of two inequalities that would represent this situation. For what we're doing in class, I don't want you guys to graph these. They're kind of annoying to graph. But if we needed to, we certainly could graph them and find some combination of hours we could work at each job to satisfy these conditions. And the other type of problem you may encounter where you have to write a system of inequalities would be based on a graph you see. So let's go ahead and write two inequalities that would represent this situation and then get us this as our shaded answer. So if you want to do this in colors, I'm going to go ahead and change their boring blue to a couple other colors so I can see what I'm doing a little bit better. So let's start with this dashed line. Now, because I can see the y-intercept, I can just find the slope. I won't need to really do any calculations. I can get my y-intercept and my slope just from the diagram. So I'm going to start to write out what I know. I'm going to put down a y. I'm going to skip my inequality symbol, and then it's a fill-in-the-blank problem. Y equals something times x plus something else. That first something is going to be my slope. That second something is going to be my y-intercept, my b value. And again, we should be able to get that right from the graph without having to do any calculations. So from my graph, I can see that my y-intercept of the orange line is -1. So I'm going to put a plus -1 right there, or just -1. And then my slope, just go ahead and find 2 points on your graph and make your little step, and I can see that my slope is just continually up 1 over 1, up 1 over 1, or in other words, just a slope of 1. Now, as far as your inequality symbol goes, you're going to have to look at where the graph has been shaded. And again, that's this dark blue section over here. And I can see that for the dashed orange line, my graph was shaded underneath that line. So I'm going to use a less than symbol. Y is less than 1x plus -1. And then next I would need to determine whether I use an equal to sign or not. But because that line is dashed, I'm just going to have y is less than. So there's one of our two inequalities. I'm going to switch colors. Let's go with green. And I'm going to look at the solid green line in this direction now and write that inequality as well. So start out the same way, y, and then skip your inequality symbol. We're not sure what it's going to be yet. I'm going to fill in 2 blanks. Something times x plus something else. The something else is my y-intercept, so I can see that that's a +2. So I'll include that. And then my slope is a little more complicated this time. Find 2 points on your graph again, but find points that are easy to find the coordinates of, like the y-intercept would be good, and then maybe this point right here. I wouldn't want to choose, for example, like that point, because I don't really know what the coordinates are right there. So I'm going to just stick with the y-intercept and I guess the x-intercept. So make your step. I can see from that step that I rise 2 and run 3, and I'm noticing that I have a negative slope, so I'm going to make my slope negative, so negative 2/3 x plus 2. And then for your inequality symbol, again, look at where your graph has been shaded compared to that line. The shading this time is occurring above the green line, so this time I'm going to be greater than, and because that line is solid, I'm allowed to be equal to it, so I'm going to say y is greater than or equal to negative 2/3 x plus 2. So these two inequalities together should represent this system that we see visually.